today in our video. We start by learning about the different network types and the importance of an IP address in a network environment. Next, we cover the significance of switches and the working of routers in a network. Moving on, we cover the explanation of subnets in a network and the importance of network address translation or NAT. Finally, we understand how firewalls work and the distinct use cases of DMZs and port forwarding. Before moving forward, ensure you're subscribed to our channel and have hit the bell icon to never miss an update from SimplyLearn. So let's get started with the two major types of network that should be considered basic knowledge for someone starting out with networking: LANs and WANs. The first variety of networks is a local area network, also known as LAN. It comprises of cables, gateways, switches, routers, and additional parts that allow these devices to connect to private servers, cloud services, and other LANs via larger networks. The growth of virtualization has also sped up the creation of virtual LANs, which let network managers divide and logically organize network nodes without having to make significant modifications to the infrastructure. The computers in each department could be conceptually linked to the same switch in an office with many departments, be it accountancy, IT support, and administration. Still, they might be segregated to operate separately. The benefits of a LAN are similar to those of any collection of connected devices. They may access and even control one another, exchange files, print to shared printers, and utilize a single internet connection. To better understand this logic, let us take a sample structure. We can see the various components of a local network connection in this picture. And now we can see three different devices: a system, a laptop, and a printer. So we have these few devices that need to be connected to a single local area network. Now, to identify these devices inside the network, we need to assign an identifier to each device. So this is where an IP address can help. An IP address is a lengthy string of digits allocated to any device connected to a network that utilizes Internet Protocol as the communication medium. It's the digital equivalent of your house or workplace's mailing address. The addresses are divided into four sections separated by dots. Each traditional base 10 numeral portion represents an 8-bit binary integer which can range from 0 to 255. These four integers are expressed in normal decimal notation and then separated by dots. However, computers work with binary numbers, meaning zeros and ones, and each number in an IPv4 address represents an 8-bit binary integer, which is why none of them can be more than 255. The distribution of these IP addresses is not just limited to LAN. Every device which is a part of a network will have its own IP address as assigned by the network administrator. As seen in the picture, we can now identify each device individually by their designated IP addresses. Now, with the primary purpose of a network being the ability of multiple devices to communicate and exchange information with each other, these IP addresses serve only half the purpose, since allotment and identification of these addresses need to be managed automatically and on demand. If the laptop shown on the left of the screen wants to use the printer in the network, it needs to know which particular device, or more precisely, which particular IP address to communicate with. This is where a switch comes into play. It takes the role of the delegation of commands in a particular network. Let's learn more about switches in detail. A network switch joins devices in a network, such as computers, printers, wireless access points, and allows them to communicate with each other by exchanging data packets. They can be both physical hardware devices that handle real networks or software based virtual devices. The vast majority of network equipment in modern data networks are switches. They link desktop PCs, access points, automated equipment, and some IoT devices via wired connections, such as card entry systems. They link the computers in data centers that run virtual machines or VMs, as well as the actual server and most of the storage equipment. Based on the type of switches employed, they can either differentiate between network devices using either their IP addresses or MAC addresses, which are separate types of addresses allotted to each hardware device, irrespective of the network it is connected to. Now that we understand the major parts of a local area network, a major query that may come to your mind is how can these local networks then communicate with other networks? A router is employed at the forefront of every network setup to facilitate communication between foreign networks. This router can then be used to connect to the internet so we can communicate with the loved ones from the comfort of our own homes. So let's learn a little more about routers. The router is a physical or virtualized internetworking equipment that receives, analyzes, and transmits data packets across computer networks. The router checks a data packet's destination IP address and utilizes headers and forwarding tables to determine the best path to transport the packet. Consider the router to be an air traffic controller and data packets to be airplanes flying to various airports or networks in this case. Each package, like each jet, has a unique destination and must be steered to its destination as effectively as possible. A router helps direct these data packets to their intended IP addresses in the same manner that the air traffic controller ensures that flights arrive at their destination without getting lost or experiencing severe disruptions. A router employs an internal routing table, which is a collection of pathways to multiple network destinations to properly direct packets. It scans the header of a packet to establish its destination, then consults the routing table to find the most efficient way to their destination. The packet is subsequently sent to the next network along the route. A router also has an IP address, which is often called as the network gateway. A crucial part of a networking setup is determining whether a particular piece of hardware is a part of local network or a foreign device. As you already know, specific IP addresses exist for each device in a network, be it a local or wide area network. All these IP addresses must belong to a particular range of addresses, which are often known as the subnet or subnetwork, and which help determine the overall range of a local area network. For example, the IP addresses that can be seen on the screen right now belong to a subnet that is 255.255.0.0. The first two flags denote fixed values that must be present in every single IP address of every single device in this particular network. In our case, the 192.168 is the consistent factor in every single IP address shown on the screen. This implies that if the devices can connect to a piece of equipment with an IP address and it starts from 192.168, that device will most likely be in the same local area network. The last two places are the free ranges in this example, which means they can be any number less than 255, further helping the router and switch differentiate between multiple IP addresses in a network. With that being said, we can now take a look at how wide area networks work. A wide area network, or a WAN, is in its most basic form a collection of local area networks or any other networks that interact with one another. A wide area network is essentially a network of networks, with the internet serving as the world's biggest one. However, when a router communicates with devices outside a local network, it tends to mask the internally allocated IP addresses and uses a single public IP address for all the devices. This process is called network address translation or NAT IP allocation. A network address translation is the method of translating one IP address to another while these packets are in transit through a router. This improves security and reduces the number of IP addresses required by a company. Once a router receives some particular information that must be transmitted to a local device in the network, it checks the internal routing tables to determine the correct internal IP address and the correct destination to send the externally received data to. But let's say a device from the external network or a wide area network wants to communicate directly with a device from the local network. This cannot be allowed since this can be a very big security risk for devices in a secure environment. All of this entry and exit rule creation and handling can be taken care of by a firewall. A firewall is a type of network security device that analyzes the incoming and outgoing networking traffic and allows or denies data packets depending on a set of security rules. Its objective is to provide a barrier between your local network and external traffic, such as the internet. The most common sort of firewall, which are packet filtering firewalls, check packets and prevent them from getting through if they do not meet an established security rule set. This sort of firewall examines the packet's destination and source IP addresses. If the packet fits an allowed rule on the firewall, they are permitted to access the network. But let's say we, as users, want to allow external requests to reach individual computers or devices on our local network. There are two ways to facilitate this behavior. The first way to go through this step is by using a DMZ, which stands for a demilitarized zone. Instead of communicating directly with the local network device, the external data is sent to the router instead. The router will have created a DMZ subnetwork with only those devices added to it that require the external information to reach them unaltered. Once the data is received by the router, it passes it on to the DMZ subnet and subsequently to all the devices which are a part of that subnet. However, since the external data can reach devices in a network without any firewall checks if they are a part of the DMZ subnet, the security risks associated with this method are very large compared to the second variant, which is port forwarding. Port forwarding is a method of granting external devices access to computers on private networks. It accomplishes this by translating an external IP address and port to an internal IP address and port. All the devices talk to each other and the network gateway using the IP addresses and specific ports. For example, the TCP IP protocol, Basic Internet Usage, uses port 80 on every network. Similarly, we can create additional firewall rules to open up certain ports for external devices to communicate with. If the designated ports are open during communication, the firewall will allow the external network device or server to communicate directly with the local network device without any hindrance. That's all we really need to know for now about the basics of network.